So what we're going to do today is we're going to cover lesson 9.2. The title of the lesson is Circles, and so we're going to learn about circles. We're going to see how circles are related to the distance formula. First, we're going to read the definition. The definition of a circle is the one that you learned in geometry. A circle is the set of all points in a plane that are a fixed distance, called the radius, from a fixed point, called the center. So if you go to the other board, I drew a circle. Sadly, I drew it with a red marker, so it's possible that you don't see it very clearly. Here is the center. I use the letter C. And I'll give it coordinates. This is a fixed point, so you know its coordinates. So H and K are actually known. This point is on the circle. It's an arbitrary point. We don't know it. It could be any of those points. Because you don't know its coordinates, we'll call them X and Y. So both X and Y are unknown, and they represent the infinite number of points that are on the circle. But there is something else that we know. We know the distance from C to P. The distance from C to P is equal to R. So you're right. The distance from C to P is equal to R. We use the distance formula, and we have x minus h quantity squared plus y minus k quantity squared is equal to R. We square both sides, and we have x minus h squared plus y minus k squared is equal to R squared. This is known as the standard equation of a circle. Let's write down what each letter represents. H is the x coordinate of the center. K is the y coordinate of the center. Both H and K are known. They're fixed. What about R? R is the distance from the center to any point on the circle. So R is the radius. And what about X and Y? Well, X and Y are unknown. So they are unknown. They represent the X and the Y coordinates of any point on the circle. Let's do a few examples now. Again, standard equation, H, K, R, X, and Y. If you want, you can pause the video, copy the formula, because we're going to use it over and over again in this lesson. Let's take a look at the first example. The first example is going to be done in two ways, not just one way. So the first way of doing this problem, we plot the center. We go 2 to the left, 5 up. So 2 to the left, 5 up. We draw a point there. We notice that the radius is 3, so we draw the circle. We go 3 down, we go 3 up, we go 3 to the left and 3 to the right. And to the best of our ability, we draw a circle. So this point is negative 2, 5. We choose an arbitrary point. We do not know it. We call it x, y. And we know that the distance from the center to that point is equal to 3. Using the distance formula, we have the square root of x minus negative 2 squared plus y minus 5 squared is equal to 3. We square both sides, and we get x plus 2 quantity squared plus y minus 5 quantity squared is equal to 9. So this is one way of doing this problem. You notice that even though we know the formula, we ignored it completely. What's the second way of doing the problem? So this would be method 2. Start by writing the formula. X minus h quantity squared plus y minus k quantity squared is equal to r squared. Read the problem carefully. There are hints given to you. The word center is a hint. You are told the center is at the point negative 2 comma 5. Let's see what that means. Center, negative 2 comma 5. We know that the center usually has coordinates h, comma, k. From here we can see h matches up with negative 2, k matches up with 5, so we know our h and k. The other clue is really spelled out for us. Radius 3. Oh, guess what? That means that r is equal to 3. We know our h, we know our k, we know our r. We replace them by negative 2, 5, and 3 respectively. So x minus negative 2 squared plus y minus 5 squared is equal to 3 squared. Compare the two answers. What do you notice? Well, of course they're the same, because they're the answer to the same problem. In one of them, you visually see exactly what you did. You drew the circle, you drew the center, you drew a point, and you used the distance formula to find the equation. In the other one, you used the formula, identified h, k, and r, replaced them, and you got the answer. Either method works just fine. You can use whichever you please. In the next example, what we're going to do, an equation is already given to us, and what we want to do is just graph the circle. In order for us to graph the circle, we will identify the center and the radius, and then we're going to graph the circle. The first thing that I'm going to do is I'm going to write the formula, the standard formula for the equation of a circle. X minus 2 squared plus, instead of writing y plus 6, I will write this as y minus negative 6 squared. And instead of writing 4, I'm going to write 2 squared. Why would I do that? So that it matches, the above equation matches perfectly with the standard form for the equation of a circle. So let's see. If we look very carefully, the x matches with the x, the minus with the minus, and the h with the 2. Conclusion, h must be equal to 2. Y matches with the y, minus with a minus, k with a negative 6. So k must be equal to negative 6. For the last one, either the r squared matches with the 4, which means that r is 2, or the quantity of r squared matches with the quantity 2 squared. Again, r must be 2. So you know the center, and you know the radius of our circle. Center, 2, negative 6. Radius, 2. We draw the y-axis, we draw the x-axis, we plot the center, and then we draw the circle. We go 2 to the right, we go 6 down, and we plot the center. The radius is 2. From the center, go 2 units to the right, go 2 units up, go 2 units to the left. and go 2 units down. To the best of your ability, draw a circle. I'm going to use dashed lines because it's easier for me to draw it with dashed lines at first. And then I'm going to draw my circle. It's not much of a circle, but there it is.